Let's continue with the remaining advanced machining operations. This is about laser beam machining. As the name implies, we are using a laser, and once we focus the tip of this laser onto our workpiece, then we can increase the temperature of our actually part, and it will be melted, evaporated, and with the help of it, we will be removing material and doing the manufacturing operation. And in this process, we don't need to have a special environment. We don't need to have a vacuum environment. And this can be done on the metal part, non-metal part. So it's a flexible process. And we may be using different types of lasers like carbon dioxide, neodymium, yttrium type of lasers or diode, or even fiber laser can be used in this process. And we should be careful about some properties of the workpieces which are going to be machines in this process. The important ones are the reflectivity and thermal conductivity. For instance, if your part is highly reflective, then you cannot focus the energy. You cannot focus the laser beam. So that's why highly reflective materials are not preferred in this process. And lastly, if the thermal conductivity of the workpiece is very high, then that means you cannot focus the energy, increase the temperature at that point, and we will not be able to do this process. So we prefer to do this process on a surface having low reflectivity and having low thermal conductivity. We can even do it to see some, if you rotate the head of your laser, then you can have such angled holes easily machined. You can work on non-metal parts, even non-metal parts, so it doesn't matter. And since the temperature is quite high, we are evaporating the material. The regions actually which are beside the removed regions have kind of high temperatures, and these are called as heat effect zone. And again, as in the case of let's say wire EDM and solving, we have a curve, and we need to be careful about the width of this curve, if it's fine for our applications or not. Then we have another advanced machining process, electron beam machining. But before that, I would like to mention about little about this microjet process. It's a very special one. There's only one company working on this technology. It's Sinova from Switzerland. What they are doing is that they're actually streaming laser through this water. So you see, water is guided with the help of laser is guided with the help of the water. Laser beam is actually hitting the surface of the water stream and then going into the or moving into the workpiece. And what are the advantages with the help of it? Actually, the temperatures are decreased. The workpiece doesn't have high temperatures. Another case is that we don't have actually a weld splatter with type of this approach. So it's a nice approach, especially for opening very thin holes, very small diameter holes. Now let's have a look at electron beam machining. As the name implies, this time instead of laser beam, we are using electron beam, and it's a typical schematic of a machine. This time we need to use a vacuum chamber. Otherwise, the electrons will generate some sparks, fire. So you should be doing this process in a vacuum chamber. And this time, we remove material with the help of the high kinetic energy of the electron. So the speed, the velocity of the electrons are very high, and then once they hit the workpiece, they remove material with the help of their energies. And this is actually a bit better than laser beam etching in terms of surface finish and the width of the curve. So if these are important for you, then you may go with electron beam etching. But the thing is that uh, you need to do it in a vacuum environment, and this actually increases the cost of these machines. And another thing is that the beams might be hazardous, so that's why you need to be careful about it, and You need to have high skills, high experience to use such machines. Then we have a similar, let's say, machining process called as plasma cutting. As the name implies, once again, we need to be using plasma beams. With the help of it, you can machine, you can cut some ferrous and non-ferrous sheets and very even thicker workpiece into smaller parts. And in this process, the material rate is quite higher since the temperature can be increased to very high levels, and with the help of pressure, the parts can be, the material can be removed, and we can have a cutting process. Then we have with different advanced machining process. It's called water jet machining, and as again name implies, we are using high-speed water actually to remove material. So this is the main material remove mechanism, and we can use this process on metals, on even non-metals, composite type of materials which are highly difficult to machine with different operations. But water jet machining is a very nice one. Since we are using water, obviously, we don't have high temperatures around, we don't have heat affected zone. It's an advantage of it. And as in the case of other advanced machining operations, we don't have sharp cutting edges. So for the fabrication, for the machining of composites or different bricks such as leather or wood products, people prefer to use water jet machining. And here you can see an example, a sketch schematic of this machine. Workpiece, as you see, we have high pressure water. While it's actually heating this workpiece, it removes material. And the thing about this process is that, as you see, at the tip of this nozzle, the width of our water jet is thin, but as it goes, the width actually increases. So in an exaggerated view, let's say you have such a workpiece, okay? You cannot have a constant diameter hole or opening. So, but this is a workpiece. At the bottom of your workpiece, the width of your opening will be quite longer, larger compared to the width at the top of your workpiece. So that's an important point, and you need to be careful about it and design your parts accordingly. And we have a bit different version of this process. It's called as abrasive water jet machining. The only difference is that with respect to the previous one, we have abrasive particles actually inside the water jet. So with the help of it, you can increase the material rate since in some cases water is not actually powerful enough to remove material. So once you add these extra particles, little particles, the material rate is improved, and you can machine, you can work on a bit harder, difficult materials. Then we have another similar process which is called as abrasive jet machining. This time we are not using water, but instead we are using jet of dry air, nitrogen, carbon dioxide. And again, in this process, we need to be using abrasive particles. So at these high speed, these abrasive particles are hitting the workpieces and removing material, opening some grooves or opening different shapes on our workpiece. And again, we can use this process on metals and non-metals, on brittle parts, on harder workpieces. So it's another solution for such difficult materials. And lastly, we can say that if any of these advanced processes, advanced machine processes are not enough, then you may think about joining these processes in the same setup so that the advantages will be combined into a single setup, and we can take advantage of all these capabilities and try to produce much more complicated processes. And we have an example configuration. For instance, you may be doing abrasive machining and also electrochemical machining on the same setup. So with the help of such a setup, you can take advantage of the abrasive machining and as well as the advantages of electrochemical machining.